Hello friends, so welcome to Kranthi Physics Tutorials. So here in this class we have to discuss about the resistors are connected in series and parallel. So in the previous chapter electrostatic potential and capacitance, in that chapter, so what we had did, so the capacitors are connected in series and parallel. So in that chapter capacitors are connected in series and parallel. First of all we discuss about the resistors are connected in series. Okay, so this is the resistor symbol. So already we know that, so the spikes, so we can draw the spikes. So this is the resistor symbol, and you must and should remember one thing: the resistor does not have positive negative terminal. So if we can connect the resistor like this, and if we can connect the resistor like this in reverse direction also, there is no change in the resistance of the resistor. So that's why resistors does not have positive negative terminals. So here in this question, so I can take minimum 3 resistors are connected in series. Okay, so here this is the first one, this is the second one, and this is the third one. So here R1, R2, R3. So 3 resistors. So here R1, R2, R3. 3 resistors are connected in series like this. So we can connect. So the end of the first one is connected to the starting of the second one. So like this we can connect and so on. Okay. So here R1, R2, R3. 3, for example, 3 resistors are connected in series like this. So this total series combination is connected to a battery terminal. So battery terminal. So we can provide a battery terminal here. Battery terminal here. So this is the place. This is the man. So battery terminal provides the potential difference between the ends of the combination. Okay. So here there is a potential difference between the two ends of the combination. Then from higher potential to lower potential, current will be flows. So here the current will be flowing from the battery, and so here I, and here also I, and here also I, and finally the total current I will be returned to the negative terminal and the circuit is completed. So here there is no another way to split the current. So that's why how much current is entered into the first resistor, so that much of current is also entered through the remaining all the resistors, and finally the same current I will be reached to the terminal, battery terminal, negative terminal. So in this way the current is flowing. So that's why for the series combination of the resistors, current is same for all the resistors. So for series combination, so where here current is same for all resistors. So all resistors. So here current is same for all resistors, but which quantity is not same? Here potential and resistance is not same for all the resistors. Okay, so but according to Ohm's law, so from Ohm's law we can write V equal to IR. So we can write V equal to IR. So V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. So according to Ohm's law, V equal to IR. So from that equation V equal to IR, here we can write for the series combination as V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. Here we don't write I1, I2, I3. Why? Because I is same for all the resistors. So that's why we can write only I. But the remaining potential and resistance are write as V1 R1, V2 R2, V3 R3. So, but here the potential is not same for all. So that's why the total potential V equal to V1 plus V2 plus V3. V1 plus V2 plus V3. So all these equations are, so substitute in this equation. So then what we get? So IR equal to IR1 plus IR2 plus IR3. So we can take, so here we can take I as common, right? So R1 plus R2 plus R3, right? So I is cancelled. So then therefore, so finally what we get? The equivalent resistance or equivalent or the effective resistance of the series combination is R1 plus R2 plus R3. R1 plus R2. So finally we get the effective resistance equation. So what is that? R equivalent equal to R1 plus R2 plus R3 and so on. Okay. So this is about the series combination. So now we have to discuss about the parallel combination. If the resistors are connected in parallel, then so which equation, effective resistance equation, so we get here. Now we will do here. Okay. So we will derive here. Now parallel combination. Okay. So parallel combination. So how we can connect the parallel combination here? So how we can connect the resistors are in parallel? Now look at the board here. Okay. So here now here we can connect the resistors are in parallel. So like this, resistors are connected in parallel like this. So here this is having the resistance R1 and this is having the R2 and this is having the R3. So for example here I can take 3 resistors and those 3 resistors are connected to the battery terminal like this. So this combination is called as a parallel combination. So here all the starting points, first ends of the resistors are connected to the positive terminal and all the second ends or last ends of the resistors are connected to the negative terminal of the battery. So this combination is called as the parallel combination. So here we provide the battery and battery provides potential difference V. So whenever the potential difference is developed, then the current is flowing from the higher potential to lower potential here. So here the current I is flowing. So and so the finally the total current I is coming to the negative terminal. Then the total circuit is completed. So but here, so whenever the current is reached this point, this junction, then there is a 3 different ways are there. So that's why the current is splits into 3 different currents, I1, I2, I3, and passing through the 3 different resistors R1, R2, R3. So here we can write I1, here we can write I2, and here we can write I3. So here also, so I1, I2, I3, and all these 3 currents are combined, and finally the total current I is reached to the negative terminal I. So here the currents are splits into 3 different. Why? Because 3 different resistors. There is a 3 different ways are there. So that's why the current is splits into 3 different currents and passing through the 3 different resistors here. So, but here for a parallel combination, so all the starting terminals are connected to the positive terminal of the battery, all the second ends of the resistors are connected to the negative terminal of the battery. So that's why the potential is same for all the resistors here for parallel combination. So here, so which quantity is same? So the potential. So so potential is same. Potential is same for all. Potential is same for all. So okay. So here according to Ohm's law. So from here from Ohm's law, so we can write V equal to IR. V equal to IR. So but here I equal to V by R. So we can write I equal to V by R. I equal to V by R. And also we can write I1 equal to V by R1. I2 equal to V by R2. And finally I3 equal to V by R3. So we can write according to Ohm's law V equal to IR. So from that I equal to V by R and I1 equal to V by R1, I2 equal to V by R2, I3 equal to V by R3. So why? Because here we can write only V. So why? Because V is same for all. So that's why we don't write as a V1, V2, V3 here. So but we can write I1 R1, I2 R2, I3 R3. So but here the current is splits into three different currents. So that's why so I equal to I1 plus I2 plus I3. So all these values are substitute in this equation. So then what we get? So V by R equal to V by R1 plus V by R2 plus V by R3. So here we can take V as common, then VV is cancelled. So in the LHS side and RHS side, so in RHS side we can take V as common. So the LHSV and RHSV both are cancelled, and finally what we get? So 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. So what we get here? Finally 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. If you can connect fourth one, fifth one, sixth one and so on. So we get it and so on. So finally this is the expression for the equivalent resistance of the resistors are connected in parallel, and R equivalent equal to R1 plus R2 plus R3 is the effective resistance for the resistors are connected in series. So this is about the resistors are connected in series and parallel, and those equivalent resistance equations are here already derived. So everybody is clear? Okay. So this is Kranthi signing off.